We just reviewed completing the square. You had two assignments where you had to complete the square. We've just done that off camera. Now we have to go through and make sure we know how to do the velocity problems, as well as finding the quadratic function given 3 points. In this problem here, the first thing you have to recognize is what formula are you going to use? Is it going to have a negative 16 in it or a negative 4.9? It's going to have a negative 16 in it. This person is standing on a ledge. 48 feet per second is the velocity that he throws a ball with, and the ledge is 30 feet high. The formula would have to be this. Let's see if my marker's in the right shape. There we go. Your height as a function of time would be negative 16t squared plus your initial velocity times t plus your initial height. And plug in the information from the problem into the function. So you have negative 16t squared. And then plus the initial velocity, which is 48 feet per second. The 48 goes here. Times t. The ledge is 30 feet tall. The height goes at the very end. You must complete the square in order to find the maximum height that the ball reaches, the time it takes to get there, and then you can solve by completing the square to get the time that it took to hit the ground when it came back. I am going to have to factor out this negative 16 and divide the first two terms by negative 16. So I'm left with what to start with? T squared. And what is 48t divided by negative 16? Negative 3t. And we'll leave a space and put a plus 30. What is half of the middle term? 1.5. What's 1.5 squared? 2.25. So we're going to add 2.25 here. But we're not adding 2.25 in reality. We are adding 2.25 times the negative 16. So 2.25 times the negative 16 is what? Negative 36. So we've really subtracted 36. Therefore, we have to add 36 on the outside. And then put it in the completed square form. Negative 16, parenthesis, variable, sign from the middle, half of the middle term, close the quantity square, and 30 plus 36 is 66. Question number 1, what is the maximum height that the ball reaches? 66 feet. And then question 2, the time that it took to get to that maximum point. How many seconds did it take to get there? 1.5. 66 comes from here, 1.5 from there. And the last question is time for it to hit the ground. This is where you have to complete the square, or actually we've completed the square, but you have to solve by completing the square. And solving it by completing the square is not difficult at all. Here's what you have to do. This is where we left off, there. You're going to write negative 16 times the quantity squared of t minus 1.5 closed quantity, and set it equal to this last term, moved to the right side, which means if you cross the equal sign, you change the sign of what you just moved. And then divide that by the negative 16, which comes from over here. Leaves you with this on the left-hand side. And to undo that quantity squared, you must do the square root of both sides. It leaves you with t, I can't erase, so I'll just scratch it out, t minus 1.5 equals the square root of negative 66 over negative 16. Now figure out what that is in the calculator. Square root of negative 66 divided by negative 16. What is it to 2 decimal places? 2.03. 2.03, yep. You need your square root symbol. It should automatically put a parenthesis up for you. Negative 66, division, negative 16. Got it? Alright, so it's going to be t minus 1.5 equals 2.03. You have 2 equations to solve from that point. One is t minus 1.5 equals 2.03, and the other is t minus 1.5 equals negative 2.03. Don't forget this is a plus or minus 2.03. It came from a square root. If you solve this very simple equation, 2.03 plus 1.5, you come up with 3.53. Over here, you get negative 2.03 plus 1.5. And negative 2.03 plus 1.5 is negative 0.53. If the ball has been in the air and is coming back to the ground, the time that it took to get there must be positive. It cannot be negative. So your answer is 3.53 seconds for the ball to hit the ground. Given 3 points, you must create the quadratic function whose graph passes through those 3 points. You must know that the general form of a quadratic function is y equals ax squared plus bx plus c. Step 1 is to figure out what the value of c is, and to do that you must find which, if any, of those points up there represents the y-intercept on the graph. Which one is it? 0, negative 21. If it's 0, negative 21, then what would be the value of c? Negative 21. So you should be able to write y equals ax squared plus bx minus 21. That's how much of the function we know so far. We have to solve for a and b next. To do that, we have to go to this point here, negative 3, negative 21, and insert it into that blue function here. If negative 21 is the y, then it goes first. Negative 21 equals a times x squared. X is negative 3. So we put a negative 3 there, plus b times the other negative 3, or another one, and then minus 21. From here it is a matter of simplifying. Negative 21 equals 9a minus 3b minus 21. Remember that negative 3, the quantity squared of negative 3, is not negative 9. From there, you can move the minus 21 from the right over to the left. And it becomes 0. This equation is the first piece in solving for a and b. You must hold it where it's at. The other point is 3, negative 3. Which one of those in that point is the y value? Negative 3. So it goes first, and then equals a times x squared, so it's 3 that's going in, and then times 3, and then minus 21. Simplify it. Quantity squared of positive 3 is 9, so we end up with 9a, and then plus 3b minus 21. Move that minus 21 over to the left-hand side, and we're going to come up with negative 3 plus 21. And that simplifies to 18. There is the second equation that you need. Got to solve a system of equations. We've had tests over this, quizzes, homework assignments, blizzard bags over solving systems of equations. So the first one is 9a plus 3b equals 18. That's what we just finished. And the other one is 9a minus 3b equals 0. You put them together. Fortunately, we already have everything we need. We have 2 9s on our a's and we have 2 3s on our b's. Signs are opposite though. But since the 9a's are already in place, all we have to do is subtract. 9a minus 9a is nothing. So they are gone. 3b minus a negative 3b is 6b. It is not 0. 18 minus 0 is 18. 18 divided by 6 is 3. So there is b. And if we want a, we have to plug 3 back into it, or into one of those other equations. We can use the top one, 9a plus 3b, and instead of b, we're putting in the 3 that we just solved for, and set that equal to 18. So that is 9a plus 9 equals 18. 18 minus 9 is going to be 9. And divide 9 by 9 to get a 1. This is not the solution to the problem. If you quit there, you still won't get it. You have to put a, b, and c into that general form, which again is y equals ax squared plus bx plus c. And the a that we just found is 1. Do not write 1x squared. Just write x squared. When we solved for b, it came back to be a 3, so we put in plus 3x. And the c that we had way back from the beginning was minus 21. This is the function that passes through the 3 points.